Hello everyone and welcome back to Anupam Tech Talk. In today's episode, we are going to talk about a concept that's fundamental to backend development and system performance, database indexing. We all expect application to return data almost instantly. But what happens when our database contains millions or even billions of records? How does the database find exactly what we need without checking every single row? One of the key answer is indexing. So today let's understand what a database index is, why we need it, and how it can make our application significantly faster. So let's talk about the problem. Imagine we have a table containing 10 million users record. Now, suppose a user logs into the application using their email address. The application sends a query asking the database to find the user with that particular email, something like select star from user where email equals, let's say, Amit at the rate example.com. The question is, how does the database find that user? If the database has to check every row one by one, that could becomes very expensive, especially as the table grows. This is where indexing becomes extremely useful. So let's talk about what happens without an index. Without an appropriate index, the database may needs to examine a large number of rows to find the data. Think about looking for a name in the Hug book that has no index or a table of contents. You'd potentially have to go page by page until you find what you are looking for. The database has a similar problem. This is called a full table scan. The larger the table becomes, the more expensive this type of search can become, and this can directly affect the application performance. So let's talk about what is an index. So what exactly is the database index? A database index is a data structure that helps the database find the record more efficiently. A simple way to understand it is to compare it with the index of a book. Imagine you have a 500 pages technical book and you want to find a particular topic. Instead of reading all 500 pages, you go to the index, find the topic, and jump directly to the relevant page. A database index works on the similar principle. It provides the database with a much faster way to scale and locate the required data. So let's talk about what happens with index. Let's create an index on the email column. When the database receives our query, it can use that index to locate the matching record and much more efficiently. Instead of potentially scanning millions of rows, the database navigates through the index and quickly identifies where the required record is located. This is one of the reasons indexes are so important when you are designing a system that needs to handle a large amount of data. So let's take an example. We can create an index on the email column using a statement like create index dash underscore user underscore email on user's email. Now, when we search for the user based on their email, the database can potentially use this index to make the lookup much faster. Of course, the exact behavior depends on the database engine, the query, the database distribution, and the execution plan. So, indexing is not simply about adding an index to every column. We need to understand how our application actually queries the database. So, we need to have a right trade-off. There is an important point here. Indexes are not free. They can significantly improve read performance, but they also have a cost. An index requires additional storage, typically somewhere around 10 to 20% of the table size per index. And whenever we insert, update, or delete a data, the database may also need to update the indexes. This adds extra work and can slow down write operation. So having too many indexes can actually hurt with performance. That's why a good database design is about finding the right balance between read performance, write performance, storage, and query pattern. So let's talk about when should we use indexes. When should we consider creating an index? A good starting point is columns that are frequently used for search. For example, column columns used in where conditions. Columns frequently used for joins can also be a good candidate for indexes. And depending on the database and query patterns, columns used for sorting or filtering, like order by or group by, can benefit from indexes as well. But we should always look at the actual queries and database execution plans instead of blindly creating indexes. And this brings us to an important engineering lesson. We should not add an index simply because we think it might make things faster. We should first understand the problem, which query is slow, how much data are processing, what does the database execution plan. Then we can make an optimization and measure the result again. This is an important engineering mindset. Measure first, optimize second. Performance optimization should be based on the evidence, not assumptions. So let's quickly summarize today's discussion. First, a database index helps the database find data faster. Indexes becomes especially valuable as our data set grows. Indexes also have costs, including storage and additional work during writes. We should not create indexes blindly. And finally, as engineers, we should always measure the problem, understand the query, analyze the execution plan, optimize, and then measure again. I leave you with the thoughts: measure first, optimize second. This mindset applies not just to database indexing, but to all performance optimization work we do as engineers. And that's it for today's episode. Database indexing may look like a small technical detail, but understanding the concepts like this helps us build applications that can scale as the amount of data grows. If you found this episode helpful, please like the video, subscribe to Anupam Tech Talk, and share it with someone who might find this helpful. I'll see you in the next episode where we will continue exploring practical engineering concepts and how they influence the system we build. Thank you for watching.